Hi, it's Jan Beta, and I figured that I haven't done Commodore 64 content in a while, so I think it's time to do a little Commodore 64 troubleshooting, maybe repair, hopefully, video again. And for that purpose I have this board, which is one of 4 boards that got donated to me by Adam recently. It's missing all the custom ICs, the MOS ICs. I put that in there actually. The 8701 chip, I put that already in there because I just had one lying on the bench here. I got these for basically salvaging the parts to build new C64s or new PCBs that are now being produced by Rob Taylor, who makes these and sells these, also known as Pipo UK, who also did the Amiga 500++ board. He replicated a couple of different versions of the Commodore 64 boards and sells these. I'm going to link his store below. I'm going to build some of those at some point. That's why I got these boards in the first place. Let me use this opportunity for kind of a cheesy segue. Some of the boards I mentioned were produced by PCBWay, who also happen to be the sponsor for this video. And if you want your own prototype PCBs manufactured, PCBWay is definitely a good place to look for good quality PCBs and really great service. Thanks for sponsoring this video and many other videos on this channel, PCBWay. So while some of these boards that I got donated have trace damages and are in rather bad shape, this one actually looks quite okay. And Adam, helpful as he is, also wrote down that it has a black screen. I'm going to attempt to fix this. It actually looks nice, and it is a 250425 board, which is the second to last newest version of the long board that was used in the classic bread bin Commodore 64s. They are my favorite boards to work on, so this is hopefully going to be fun and maybe informative for you, seeing me troubleshooting this. So obviously before I can even start troubleshooting this, I'll have to populate all the empty sockets there. And I'm going to spray some contact cleaner into the contacts, because some of these sockets, especially these ones, are single wipe. I think they're all actually single wipe. That means the little contacts only grab from one side. So you can probably see that these contacts are only contacting from the inner side of the IC. There are versions that have contacts on both sides that are a bit better. Especially these ones are particularly prone to not making good contact, so I saw a lot of these kinds of sockets fail. These are also pretty bad. I guess Commodore just cheaped out on the sockets. At least this board is fully socketed, which is kind of a nice touch. I'm going to spray some contact cleaner in there to kind of make the possibility of the sockets not making good contact a bit smaller. Okay, actually, upon looking over the board, I think I already know what the trouble with this board is. Do you already see it as well? If you've followed my videos, you probably have heard me talking about this stuff already. So these 8 chips here in this lower left area of the board are the RAM chips, the actual 64 kilobytes of RAM. And these are MT brand. These chips are very, very likely to fail, even if they are not in use at all. They just fail from lying around, basically. There's something wrong with the chemicals in there and the layers just disintegrate or something. These are very likely to be the cause of the black screen. RAM faults are a cause of a black screen in the Commodore 64s very, very often. And these RAM chips are particularly prone to failure. So these are my main suspects, even without having any closer look at this or trying to power it on. But I'm still going to populate all the sockets with the ICs and see what this actually does. So before I even put the chips in, I thought it might be a good idea to just measure the voltages coming from the power supply. So this should be our 5 volts, yeah, which is 5.08. Our AC, you can always see there's a little gap in the user port connector. This is the 5 volts, and the other ones should be the 9 volts AC, which should be high because we don't have anything hooked up in the computer that draws current. So yeah, 11. Yeah, that's actually correct. Another point where you want to measure, or the other 2 points, are these voltage regulators. This one should be outputting 5 volts. That is on the rightmost pin, or facing this way in this case. This should be spot on 5.07. Yeah, 5 volts, and this should be 12 volts. Yes, so these are all the power lines that you have basically, except for some 9 volt unregulated line that powers the dataset port. Yeah, there we are, 6.9. That's this pin, I think. That's 5, and this is the 9 volt unregulated, which is around 7 volts in this case. Okay, so the power rails are good on this board, it seems. At least there's no overvoltage, and the voltage regulators do what they're supposed to do, so we're not risking damaging any chips. There's still kind of a risk to damaging chips, because you never know what else is going on the board with the capacitors and stuff, but at least for a quick inspection, this tells me that the board is safe to put chips in and see. So I'm actually going to have to gather my chips from all kinds of sources, because I don't have a whole set of Commodore 64 chips spare, I think. But I have a couple of strips, so we are going to see where we get them from. Probably I'm just going to put those that I have in there and take the other ones out of a working C64 for now. So I have all the ICs populated now, except for the SID sound chip, which is not necessary to actually run the machine. And I don't have a spare one, so I just left that open for now. The other stuff should all be working chips. Not quite sure about the CIA, the second CIA here. It says question mark, but I think this probably works. Just suspected it to not work in some other system. The other chips should be fine. Yeah, so this should now be able to run a dead test cartridge in order to troubleshoot this further. Let's see what it actually does. Oh, by the way, the dead test cartridge, this is my self-made one. Not very nice looking, but it works. The difference between the dead test and the diagnostics cartridge, that's 2 different things. The dead test is a cartridge that works without any extra hardware connected to the system. And it can also work with half the system not working. I believe you need the processor, the PLA, and some other bits to work, and the VIC2 to halfway work for this to be able to output. And the ROMs are not necessary for this to work. It has its own, it overrides the kernel ROM, and it has its own character ROM and stuff like that. So you can use this to troubleshoot machines that are really severely dead, and it will still do things like flash the screen for RAM faults and things like that. So I'm hoping that this at least flashes the screen and tells me that the RAM is faulty in this one, which is what I suspect, kind of, sort of. I'm kind of sure that the RAM is defective in this one. Maybe there's other faults too. Let's see what it does actually. The Commodore 64 Diagnostics cartridge, on the other hand, is a cartridge that basically needs most of the system to work, and you can do like in-depth testing of the ports and stuff like that. So it has these loopback cables that connect to the user port through a little circuit board, and you can connect all these extra cables so that it does loopback tests for determining the ports are all right. So the dead test is literally for testing dead machines and troubleshooting, initial troubleshooting, I guess, and the diagnostics are used for determining that the machine actually properly works, if we get it to work halfway. So yeah, that's the difference between the two. I recommend if you're getting one of those and want to do C64 repairs, get a dead test, because it's much more useful for testing black screen, which is like the most common fault in C64 is probably black screen machine. So yeah, that test is recommended for that. That was the first one I had actually, and still use it all the time. Okay, initial testing. Let's see if this does anything. Okay, so we get a so we get a signal from the dead test. That's actually flashing the screen to determine which of the RAM chips is faulty. We get 6 flashes, if I counted correctly. 1, 2, 3, 4, 5, 6. Pause. If the dead test does these flashes, it indicates a problem with the RAM. Okay, so let's have a look at the manual for determining which of these empty RAM chips is actually the culprit. I kind of suspect that more of these are defective, so yeah, usually what I do is just replace all of them as kind of preventative maintenance, because they all break over time. These are really, really, really prone to failure. So if you have a C64 with MT chips, you basically don't even have to look any further. But these are the culprit probably. Of course, there still might be more things wrong with this machine. But yeah, definitely RAM problem at first. Let's address that. So here's the manual for the dead test cartridge. And as you can see, 6 flash codes refer to the chip with the designator U22 on the C64 ref AB, which I believe this is. At least the numbers on the chips are corresponding to that. So U22 is the one that the dead test detects as defective. So U22 is this one, which we will now desolder using my desoldering station and replace with a known working one. And then try again to start this. I always tend to mark the chip I want to desolder from the backside so I don't get chips confused, because that happened to me before. And desoldering the wrong chip is, yeah, kind of frustrating. Okay, got most of them. Just going to add some fresh solder to the ones I missed. Didn't come out yet. Because that helps with heat conductivity. So it's, even if this might seem counterintuitive, often helps to get stuff out if you add fresh solder. It also would help to clean this. I think it's maybe it's clogged up because I didn't clean this properly last time. Okay, hang on. That's actually something you have to do quite regularly with these things. Of course, obviously. Basically, you would have to clean this every time after use. But it's not that bad. You get used to it. It's not that difficult to do. So, should remove the solder from here. Yeah, a lot more suction there. I wiggle the pins and see if they are loose. You can easily determine that. And then I basically go in from the top and carefully with the screwdriver lever it out. If it needs any force, you have to do more desoldering. In this case, it just came out. There's those traces underneath there that are easily damaged if you do it like this. You can also use the chip puller, of course, or something like that. I like to have a bit of a longer arm here, so I can lever it out better. But yeah, I wouldn't recommend using a screwdriver necessarily. I would rather do it with a chip puller or something like that if you are not certain. And if you need any force at all, you didn't desolder it fully yet, so you have to go back to desoldering. Well, you can also use hot air to get the rest of the solder away and just pull it out while heating up the solder joints. It's a nice method as well. Okay, so let's put another chip in and see if that fixes our problem. I tend to put in a socket whenever I desolder an IC, so it's easier to work on this particular IC later. Remove it. Okay, so that's it. Fortunately, I bought quite a few of these 4164 RAM chips. These are actually 4264s, but they are the same chips, basically. So let's see if these actually work, or if this one actually works. These are of course new old stock, but at least they are not MT branded, so chances are they are just going to work. Most other brands are quite reliable, really, compared to the MT branded ones. Okay, maybe that was the whole problem. Let's see. Okay, I have the dead test reconnected. Let's see what it actually does. If it actually does anything. Oh, now it blinks one time. Okay, probably another RAM chip. But at least we seem to have changed the fault. Let's see if it does the same on each power on. 1. 1. Yeah. So, another bad RAM chip. Okay, one blink actually means U12. Let's replace that as well. Yay! Okay, U12 is this one. Okay, same procedure basically. And of course, another big advantage of using sockets is that you are not applying any heat to the new IC you're going to insert, which of course is always a risk for semiconductors. Okay, in goes the next RAM chip. Quite happy I bought so many. There we go. Okay, next try. Okay, it still says U12. Yeah, it still says U12. Kind of suspect different ones though. This one gets really hot. Yeah, there's another one that gets really hot. I guess that's also broken. The dead test is not really accurate all the time, so it's just a bit of a, yeah, kind of a help to determine whether it's RAM. This here, U24 actually gets really warm, so that's usually kind of a sign for this chip being borked. So I'm just going to replace that too. Maybe I should just replace all of these. Maybe that's the best idea. For now I'm just going to go with this one and see if that changes anything, I guess. Okay, let's just do this. The same procedure as with, with the other chip. Okay, next one. Let's see if that does change anything. No, it still says chip 12. So I think I'm just going to go ahead and actually replace all of these, I guess. Yeah. There's also others that get really warm. I'm just going to go ahead and replace all of those chips because they're all bad probably. Yeah, that's the easiest thing to do. So, a longer soldering montage, and I'm just going to replace all the RAM chips with sockets and then with actual new RAM chips. Okay, got all the new RAM chips in. I had to improvise a bit with the sockets because I was running out of proper sockets and had to cut these to size, which usually is not a problem. You just cut some pins off. You can also use these pin header rows, just cut them to size and put two in parallel and use that as a IC socket. Doesn't look that great. Maybe I'm going to go in at a later point and replace that actually. So yeah, let's just try if this helped fix it, maybe, hopefully. Fingers crossed. Let's see what this does. Okay, that's promising. Screen stays black. The dead test needs a while to start up actually. There it is! Yes! Okay, that's very, very promising. Yeah, it seems like. Let's just keep this running for a while. Picture quality is not great. Apart from me setting the aspect ratio incorrectly. It's a cheapo upscaler and it is an old VIC-2 chip which has an inferior quality and the board hasn't been recapped. But it seems to be fixed. We have a CAA problem. I can see that by the timers being off. So the CAA with the question mark probably is not quite alright. Going to replace that with the proper one, I guess. But other than that, the RAM seems to have been the main reason why this wasn't working. So, nice. So what we basically have in the dead test is these two timers, which are the time of day, the TOD clocks in the CAA chips. And these should be running in parallel, so you should have the same value on there, but they aren't in this case. So one of the CAAs is borked, and I think this is the right one. I think this is the right one. This is the left one from the point of view we're looking at it. So the one with the question mark that I marked with the question mark actually is broken. Okay, I'm just going to put another CAA chip, 6526 CAA chip into this. Okay, there we go. This should now be fully functional, minus the sound, because we don't have a SID chip in there. Yeah, let's try. Yeah, and that's what it's actually supposed to do. One counter is at AM and one is PM. So you have the same values, but one is AM and one is PM, basically. And if that looks like this, chances are the CAAs are completely alright. Which in this case, I believe they are. Yeah, nice. Now we should get the normal basic screen as well, I guess. Without the dead test. Which we do. No problems whatsoever. So I consider this Commodore 64 fixed now. I am going to run some additional tests. Unfortunately, I can't leave this as a full machine because I don't have enough ICs for all the Commodore 64 boards I have. So if you happen to have Commodore 64 ICs or maybe populated Commodore 64 boards, broken or working, and are looking for a place for them to live, maybe consider donating them. I would be very happy about that because I don't have a lot of money at the moment, and these spare chips can be really expensive, and I still want to fix as many Commodore 64s as I can. Yeah, so that's another C64 fixed. If you have a C64 with those MT RAM chips, they are very prone to failure, and I recommend just, as I did, just getting them all out and replacing them with something more proper, basically. So anyway, thank you very much for watching. If you are a supporter, thank you ever so much for your support, and if you feel like supporting me, check out my Patreon page, which is linked below, or my channel memberships, which I have also activated recently. And of course, if you like this stuff, feel free to subscribe to this channel. There's going to be more Commodore stuff, and there's also sometimes other things, but mostly I'm focused on Commodores and repairing Commodore 64s and Amigas and alike systems. So thanks for watching. I'm Jan Beta. See you next time. Bye.